Hello, and welcome to the lab directions for our surfaces of solar system objects. All right, so in this lab, we're going to use a different piece of software that we're going to use in 2 labs this semester. This is the first of those 2 labs. And that piece of software is called ImageJ. So that's really what I want to get started in terms of how you're going to make this lab work for you. Okay, so ImageJ is a piece of basically video analysis software, image analysis software that's published by the National Institutes of Health, and you can find it easily by just Googling ImageJ. All right, so you can see here NIH ImageJ. There are quite a few different versions of ImageJ. There is a type that will run without any basically any platform. So it's the sort of an independent version of it. It will run on any system. You can have a Windows version here. There's a Linux version, and then there's a Mac version as well. Okay, and so it'll run on any system. It runs quite well. Being open source, maybe it's less flashy than paid for software, but it works well, and it definitely will not put any viruses on your computer. If you are running on a Mac, I would recommend, instead of doing ImageJ, do ImageJ Fiji, which is just a bundled version of ImageJ that works very well on modern Mac operating systems. That's what I'm going to be using here in this directions video. Okay, but ImageJ also works fine on my computer. I just run Fiji instead. Okay, so that's what you're going to want to do. Once you download the file, you of course going to want to install it on your computer. That's of course operating system dependent. It will probably tell you that this is from an unknown publisher. It doesn't recognize that it's from NIH or what NIH is, since you didn't get it from the App Store or something similar. So you're going to want to make sure that you allow it to be installed. On a Mac, for example, that is as simple as right-clicking and choosing Open rather than double-clicking, and then you'll get an option to install anyway or trust the developer. Similarly on other operating systems, you might just have to install it with administrative privileges, but you're just going to want to do that. If you're not familiar how to install a piece of software from an unknown developer, a quick Google search will show you how to do that. Okay. So then once you have ImageJ installed, then we can go on to talk more about what we're going to do in the lab. Okay? So here's some purpose about the lab. I'll let you read it. It's basically about just understanding how to analyze black and white photos and get some meaningful astronomical information from them. Okay? And so there's some more background, lookup tables. There's a pre-lab section, which I'll scroll down to. Please do note that the pre-lab is at the bottom. You're going to want to turn that in. One thing is you're going to do a coloring assignment. Then you're going to answer some kind of basic questions just to show that you're thinking about the ideas that you'll need to be doing in the lab itself. Okay? All right, so let's continue about how to use ImageJ. All right? So let's go ahead and open up a piece of software and do some of these example measurements. Okay? All right, so let's open it from here. So here I'm going to open up Fiji. And then we're going to go to our folder. Okay, so I'm going to go here. I'm going to go open. And here I have a folder called Lab 10 Images. Of course, this for me, this is on my computer. For you, you can put this on your computer and probably are going to want to download the entire folder, but you're going to find it under Files in Canvas. Okay, so that's where all these images are located. All right, and let's go ahead and open the first one that's mentioned. I think it's Moon 2. Let's double check. Yes, Moon 2. All right. So go ahead and open this up and go to Moon 2. Right. We have a crater in this image. All right. So it's a small image. We can do things like identifying the how many rows of pixels, height, and columns are there in this image. Okay. And we can do that under Image Show Info. So if we go over here, we can go to Show Info, and that's where you're going to get that information, and you're going to fill it in. So many of these first steps are just making sure that you can kind of be walk through of how to use the software. All right, it's pretty. I think the directions are pretty detailed, but I again wanted to give you just this video to help you get started, because I know downloading a piece of software can be overwhelming at first. And then this is a conceptual question. You want to carefully think about this, about what it means to be a quarter moon, where that's located in the Earth, Moon, Sun system of those three celestial bodies. So definitely a phases of the moon question. Kind of refer back to motions of the solar system to understand about that. All right, and then we can change this way, make some settings here, change the size, and so on. One good way to zoom in on image J is just to leave the cursor, that little crosshair, over a particular point, and then just do Command plus, and that will zoom in wherever your cursor was located. So for example, if I left my cursor in the upper left-hand corner, it would have zoomed in on the upper left-hand corner. But if I leave it in the middle, it will zoom in directly on the middle. So we can zoom in again. All right, and continue zooming on that image. All right. All right, and then it asks you to actually quantify the magnetization. Then you're going to here, you're actually going to look at a particular location and get the coordinates. And you can see that here if I mouse over. Let's go and click on the window. If I move my mouse around here. So this, you want it, the image J is based on these little small independent windows, and they won't always stay on top, so sometimes you have to go and find them when you're running multiple windows at a time. But if I move my little crosshair around, you can see that the actual coordinate shows up. If you look in the lower left-hand corner of the window that says Fiji is just image J, and you'll see that as I move my crosshair around, it's giving me an X and Y coordinate, as well as a value. That value is referring to the grayscale value, which was discussed in the pre-lab, as well as the introduction to the lab. Okay? All right, so you can see all the different, we can find a really dark spot, right? And if we go to a light spot, we can get different numbers as well. Okay? I think I saw something in the 200s because it gets really light over here. There we go, see? All right, so then we can get to a much darker area and get lower values. None of them are true black. Up here is some of the darkest regions, but it's still more of a gray than a black, obviously. All right, because 0 would be pure black, and we get nothing approaching that level of darkness. But there's a lot that can be gathered from basic grayscale values like that. One of which is kind of, whether there's a gap in something regarding the rings of Saturn. Another idea is kind of getting an estimate of the slope of land, because if light is shining at a certain angle, then obviously it casts shadows, or in a crater it could be dark, and on the edges of the crater it could be light, and so on. Okay, and so then there's some more information about images. So we're going to open one other image, and I'm going to show you the next bit of information, or the next functionality that you need to know in image J. Okay, so we'll go back to File, Open. And this time we're going to choose tick. Tick is named based on the fact that this crater looks like a tick. All right, see all the little legs of the tick and kind of the body of it, right? Okay, the little blood-sucking critters, ticks. Okay, so we're going to go on, talk about what it looks like, okay, and then as well as discussing what you think this is, that little rectangle, okay, and then we're going to go on and actually use this tool here, which is the line tool, and there we're going to drag a line across, and then we're going to analyze that line. So let's read this paragraph. So how wide in meters is the volcanic vent at its widest point? Use the line drag tool to drag out a line selection across the widest point of the vent from one edge to the other. Select Analyze Measure. The line length in pixels will be reported in results. Choose Analyze Plot Profile. The pixel variation along your line segment will be plotted in the window called Plot of Tick. Read the maximum and minimum pixel brightnesses. Okay, so we're going to give the width in pixels. All right, and then we have a relationship here that tells us that each pixel is worth 225 meters, which allows us to convert from pixels to meters. Okay, so let's go ahead and do that. All right, so it says here that we're going to be dragging it across, I believe, the widest section of the vent. All right, so instead of doing a vent here, or the widest section, let's do a different section, so I won't be doing your lab for you. So I'm going to go over to the line tool, but it will still be the same idea. I'm just going to do a different section. I'm going to drag it across the kind of the thorax of the tick over here. Okay, and you might want to do it from edge to edge. I'm including a little bit extra on the sides just for fun and for demonstration purposes. Okay, all right, so I've drawn my line. So one thing you can do, as mentioned in the lab, you can go to Analyze Measure. Okay, and that will give you the length. All right, gives you a lot of other information you don't care about. It gives you an area, which probably doesn't make sense for a line, but it's giving you a width of 1. So that is basically the same as the length. But go ahead and actually report the length value. You can see because it actually rounds up with the area. But there is the more accurate length value. Okay, and that's the length in pixels of the yellow line that I drew, and that's what you're going to want to report in your lab. Okay, but of course for a different line. Okay. All right. So then we want to do Analyze. So we'll leave the measurements up. I can just leave that measurement window off to the side. But with the line still up, and by the way, if I click somewhere else on the window of the main image window of image J, it'll reset, and so the line will go away. So you can see, like for example, if I just click here, the line goes away. So then I'll have to draw another one if I want to analyze it. Okay, which I'll do. All right. So then we're going to go to Analyze and then Plot Profile. Okay, And you can see that's mentioned here, plot profile, and that's going to give you all the different grayscale values along that line. Okay, so analyze plot profile. And there we are, right? We can see the variation. We can see a bit of a trend in terms of higher values over here, and that means that is a lighter region. Does that match up with the picture? Yeah, that's where we get to that particular light region over here. We kind of have one peak of lightness, where it starts off dark and then gets light. That'd be that kind of ridge there, all right? Then it kind of remains dark with some variation, including a bit of a brighter spot somewhere in the middle. That probably corresponds to this right here, right? Then it becomes dark again, which would be this swath of line. So you get the idea, right? You can really get some information from this profile of grayscale values plotted against pixel distance. Okay, so that's one of the things we're going to be doing in the lab. That is kind of front and center of the functionality of the lab. You're basically going to do the same thing for Saturn's rings. You're going to use the line tool in order to do a plot. That's going to give you a much more kind of quantifiable way of finding gaps in Saturn's rings than just kind of looking at it, because the grayscale values will show you something that you may have missed or overlooked just with just looking at with your eyes. All right, so I'll go ahead and open up the image, but I won't do the analysis for you. But let's go to File, Open, and then Saturn's rings. Here we are, very pretty image, all right? And then it'll be the same sort of thing. You draw a line, and then you'll be able to find gaps in Saturn's rings, all right? Once you do, analyze plot profile. Okay, and you're gonna sketch some of those plots, include some information, and then finally, the last part of the lab is cratering. So the extent of meteoric cratering on a planetary surface is a good measure of the age. Young objects have few meteoric craters, and many show lava flows or ice sheets or other new surfaces that have covered up those craters. Old objects, on the other hand, show many eroded meteoric impact craters recognized by their rounded, raised edges. All right, and that's due to a particular phenomenon in the basically first 500 million years of our solar system called the era of bombardment, when there was a lot more leftover comets and asteroids that were crashing into the already formed primordial planets of the solar system. So you should now take some time to survey all of the other solar system images stored on the computer, because at this point we've really only looked at 3 of them: Moon, 2, Tick, and Saturn's rings. See if you can classify them into old and young surfaces. The surfaces of some of the objects may be ambiguous if they are images taken from a long distance with insufficient detail, or if they show unfamiliar or contradictory features and terrain on different parts of the same object. But basically, you're just going to want to go through, look at them, use some of these analysis techniques, and then basically summarize them. And here it gives you a list of what they are, based on where they were taken of each of them. All right. Many of them are moons of Jupiter, moons of Saturn, moons of Uranus, and even one moon of Neptune. There are also images from Earth and Mars and Venus and so on. So it's actually really an impressive list of images. They're quite interesting. Let's go ahead and open one more up. All right. So, all right, which one would be fun to open, right? So we can see the previews of them. This is Europa. It's a moon of Jupiter. Right. You can kind of get some ideas. Canada, right? Or on Earth, of course. Callisto, another moon of Jupiter. Gaspra. Here, let's open up this meteorite, which is I believe it's a moon, but a trapped meteorite, so a very small moon. Yeah, and we can do something like this, But mostly you're just going to want to kind of more qualitatively, discuss whether they're old and kind of give your informations for why. Okay. So really, you don't have to spend too much time on each image. Because you're just going to be summarizing all of them in this one page here. Okay. And that's it for the lab. Don't forget to do the pre-lab. I hope this directions video has really helped you get started on this lab and allowed you to use a new and interesting piece of software that scientists really use, that being ImageJ. All right, well, have a great day. Bye.